On that note, we're always looking for feedback. So Christina, if you had a chance to review that CCU use message that we mentioned in the mission summary, we'll take it. And finally, we want you to know that after yesterday, the entry folks are talking about allotting additional time for entry prep, including cabin config. It's not related to today's operations, obviously, but it is going on, so you can plan for more on that tomorrow as we focus on the flyby today. That's all I have for you for now. What do you have for me?
Thank you, Jenny. That's good to hear because we were thinking the same thing. It's great to know that our minds are working the same. We are ready to go. We are looking forward to working with and for the science team, and we are just excited to be so close to finally accomplishing what we've been training for so many years. And also, we want to say thank you for that really special message from Jim Lovell. We have a pretty neat emblem up here. We have a patch that was flown on the Apollo 8 mission. And that patch is here on the Artemis 2 mission as well. And that was sent to us by the Lovell family, by Jim Lovell's son. And so that was a really special way to start the day. And he said to welcome us to the neighborhood, and it's great to be in this neighborhood. And we look forward to sharing this neighborhood with you all.
We can't wait. We see the patch, and it's looking beautiful. Thank you.
When this showed up in our office from his family, we were completely honored. And the Earthrise, which this crew is responsible for taking that photo, has been instrumental both to our crew as our ethos and values, but also just personally to myself. I had the photo up in my room as a kid, and it was part of what inspired me to keep working hard to achieve things I dreamed about. Also, we took a deep dive into the cockpit recordings around the time that picture was taken, and it turns out there was a lot of hubbub, kind of I wouldn't say fighting over cameras, but definitely everyone wanted to capture the shot, so we're happy to carry on that legacy because we often are all glued to windows and looking for cameras too.
And I'll just close. I know it looks like a piece of paper in the camera there, but that is actually the original Apollo 8 patch printed on silk that they had done before they launched, and they flew that with them on their journey around the moon, and then the family handed it over to us, as Ike said, and it's just a real honor to have that on board with us. Let's go have a great day.
We are all on board with what you told us, and to have a great day. Thank you, Integrity.
Thank you, and have a great day, Houston and Huntsville. For Avatar, all lights lit except for 15 and 16.
That is a good read on the Avatar LEDs. Thank you.
Hey, Jenny, one cleanup thing from yesterday. I did rediscover the unused chocolate snack from the DFDO. Remind me where to store that for ground analysis.
Hooray for a found snack. You can stow that in locker A1. Thank you, Reed.
A1, go in there.
Artemis II mission is a test mission of the Orion space capsule.
Artemis II will be the first time we put humans on this rocket.
We're going back to the moon because it's the next step in our journey to Mars.
We were always going to the moon.
Pushing ourselves to explore is just core to who we are. That's a part of being a human.
And liftoff. We shall return.
Continuing to test out every bit of Orion.
Coming back to Earth, 7 miles a second.
When humanity sets big goals, we can bring together genius from around the world.
You have the best people on planet Earth putting this vehicle together.
That's what's up.
To innovate for the benefit of humanity and to inspire the world through discovery.
And here we go.
Welcome to Artemis Mission Control here at Johnson Space Center in Houston, Texas. I'm Leah Cheshire Mustachio. Right now, the Artemis II crew and Mission Control are preparing to support today's lunar flyby, the first time we've sent humans around the moon in over 50 years.
Integrity, you can use the OEs and your HHP camera for the milestone words at the Apollo 13 record distance.
You'll notice that we pause every time we hear communications to and from the crew. They are the stars for today. This afternoon, the crew will have their closest approach of the moon and will surpass the record. That record just mentioned of the furthest humans have ever flown, set by the Apollo 13 astronauts in 1970. You're looking at a live view inside the Orion spacecraft and at our Artemis II crew members. They have just completed their post-sleep period, during which they conduct any hygiene and cabin setup for the day. They also had a chance to eat breakfast before we got into our daily planning conference. The flight control team here in Mission Control Houston collecting information from all consoles around the room that we could relay up to the crew ahead of this monumental day. As you can see on your right, NASA astronaut Christina Cook taking a video of NASA astronaut Victor Glover. We expect to have great views of the crew throughout the day, as well as, of course, the moon. We expect to surpass that Apollo distance record in 55 minutes and 50 seconds. We are now looking live at a camera mounted on one of the spacecraft's solar arrays, pointed to our lunar neighbor. We are currently just 14,200 miles away from the moon and 247,672 miles away from planet Earth.
Houston integrity for AGA.
Ready to copy.
Carbon dioxide 2.3, oxygen, which has the alarm, 26.3, 73.1 degrees, 10.3 psi. And one follow-on question. We understand milestone words will be directly following the conference. Will that take the place of the PAO event, or will the PAO event still take place per the timeline?
Good question, Christina. The milestone words that we exchange at the record distance at the end of the conference will take the place of the PAO timelined activity. So that'll be our moment to talk about this occasion, and after that there will be no more expected PAO words, and you can get straight into your flyby. Copy all AGA.
Okay, thank you. And final clarification, even though it's taking the place of it, it will all just be on OE1 with HHP camera, no additional video. Is that right?
Affirm.
Okay, thank you. Yep, some of us had already heard that. Sorry about the second question. We appreciate it. Talk to you soon.
No problem.
Those communications between NASA astronaut Christina Cook and Canadian Space Agency astronaut and today's Capcom, or capsule communicator, the one person here speaking with the crew right now, that is Jenny Gibbons. She is an Artemis II backup crew member here in Mission Control Houston. We are now 4 days, 18 hours, and 30 minutes into the flight of Orion for Artemis II. The Artemis II crew inside Orion lifted off atop the Space Launch System rocket on Wednesday, April 1st from NASA's Kennedy Space Center in Florida. Those 4 crew members are the first to live and work inside the Orion spacecraft, which they have named Integrity, and have been busy conducting meticulously timelined events. It was a beautiful ascent from Kennedy Space Center. One of those early events was the proximity operations demonstration, during which NASA astronaut Victor Glover, the Artemis II pilot, manually flew Orion after having just detached from the interim cryogenic propulsion stage as if they intended to dock. This was practice for future Artemis missions, during which astronauts in Orion will dock with the lunar lander that will take them to the surface of the moon. About 24 hours after launch, 25 hours actually, Orion then conducted TLI, the translunar injection burn. This 5-minute, 50-second burn committed Orion to departing high Earth orbit and set us up for today's flyby. That translunar injection burn also served as the spacecraft's deorbit burn. It slingshots Orion around the moon and sends the crew on a free return trajectory, with splashdown approximately 7:07 p.m. Central on Friday, April 10th. Last night on Flight Day 5, the crew entered the lunar sphere of influence, the point at which the pull of the moon's gravity will become stronger than the pull of Earth's. We've also been getting some great views inside the cabin of the crew members living daily life, from working out to eating, taking photos, and making memories together. But they've also been taking some beautiful views of our home planet and of the moon, and we expect many, many more of those following today's activities. These live views back inside the cabin of Orion, but before we get into flyby, let's take a minute to get reacquainted with our crew. Reed Wiseman is the Artemis II commander and a Baltimore native. He's been in space once before.
I think there was going to be some families heading into the viewing room today. If they end up showing up, could you just give us a heads up when they're there so we can just wave to them on the camera?
Absolutely.
And that was the voice of Reed Wiseman. He has been in space once before as a flight engineer.
And if they don't come, you could just lie to us and tell us that they're there. That'd be great, thanks.
We'll keep that in mind, too.
And
I'm sure they'll be here.
Wiseman also has a great sense of humor. He was aboard the International Space Station from May through November 2014 as part of Expedition 41. This was a 165-day mission during which he and his crewmates completed more than 300 science experiments in areas like human physiology, medicine, science, earth science, and astrophysics. They set a milestone for station science by completing a record 82 research hours in a single week. He also served as chief of NASA's astronaut office from December 2020 to November 2022, and here on Earth he has 2 daughters. The Artemis II pilot is Victor Glover, selected as an astronaut in 2013, when at the time he was serving as a legislative fellow in the United States Senate. His first trip to space was in November 2020, when he launched as a pilot of NASA's SpaceX Crew 1 mission. That was the first operational mission of NASA's Commercial Crew program, which resumed launching American rockets from American soil to the International Space Station since the end of the shuttle program. Victor is a U.S. Navy captain and naval aviator who served as a test pilot, racking up more than 3,500 flight hours in more than 40 different aircraft. He also became the first person to pilot Orion the other day when we saw the Prox Ops demonstration shortly after launch. He and his wife have 4 children. Mission Specialist Christina Cook is a native of Grand Rapids, Michigan. She was selected to the Astronaut Corps in 2013, the same class as Victor Glover. She served as flight engineer on the International Space Station from March 2019 to February 2020. During that time, Cook set a record for the longest single spaceflight by a woman with a total of 328 consecutive days in space. She also participated in the first ever all-female spacewalk with her friend and colleague, Jessica Meir, now living and working aboard the International Space Station yet again. Before becoming an astronaut, Christina helped build space science instruments and led scientific fieldwork in some of the most remote environments on the planet. Her hobbies include surfing, rock climbing, community service, yoga, travel, and photography, and she is certainly getting a chance to do that. First-time flyer, Canadian Space Agency astronaut Jeremy Hansen is flying to the moon as a mission specialist on the Artemis II mission. The London, Ontario native was selected as an astronaut in 2009. After that, he worked as Capcom at NASA's Mission Control Center here in Houston. Capcom stands for Capsule Communicator and is the single direct voice communicating with the astronauts in space. He also participated in training exercises like living on the ocean floor off the coast of Florida to simulate deep space exploration for 7 days. In 2017, he became the first Canadian to lead a NASA astronaut class, and he also enjoys getting out on a sailboat, rock climbing, and mountain biking. And he and his wife have 3 children. As you can see, the crew members have dimmed the cabin lights inside Orion. As they prepare for their lunar flyby, they'll be configuring the cabin as they'd like to have it to allow for proper positioning as they move about to and from the windows, taking photos of the moon. Dimming the lights also helps prevent reflections from inside Orion onto the windows. Ahead of this lunar flyby, let's dive in and explain what you can expect over the next several hours. The crew has about 6 hours allotted to make observations about the moon. Throughout the flyby, their activities have been precisely timelined. There are 5 blocks of time during which the crew will be observing the moon from Orion's windows. At any time, 2 members will be at the windows working in a pair. One crew member will be taking photos from window 2 with a blue shroud over the window. This can help prevent that glare or reflection from inside Orion. They have an 80 to 400 millimeter zoom lens to use. The other astronaut will be in window 3 using their portable computing device, you'll hear that referred to as PCD, to make annotations. Both of these crew members will make audio recordings of what they are seeing, and they'll wear headsets connected to those PCDs. Those audio recordings will be sent to the science team at a later date. We will not hear them live. The 2 crew members at the windows will swap roles and positions halfway through their timelined block. The other 2 crew members who won't be at the windows at that time will be serving in the background as support. One will be conducting the science sit reps, or situation reports. This is what we will hear live from the crew. They'll be calling down a few times each hour to discuss what they are observing. Those situation reports include how the crew is positioned, any missed targets, or anything unexpected they saw, lunar target descriptions, any hardware issues, and of course, their emotions and reactions as they fly by the moon. The other support crew member will take pictures of the astronauts at the windows and serve as camera support, providing new SD cards when needed. There's a 15-minute time frame between each observation block during which the 2 support members switch places with the crew making observations. Two views, both coming from Orion. There on the left, the inside of the spacecraft, and on the right, a view of our moon, the destination for today. During the lunar flyby today, Orion will provide astronauts with a full disk view of the lunar surface. They'll have a higher vantage point, much farther than Apollo's lunar orbits on average. And these astronauts can observe both holes and large-scale geologic features in a single view. And due to our April 1st launch date and current illumination conditions, the Artemis II astronauts have become the first humans to directly observe certain far-side regions of the moon with unaided eyes. Great, thank you. You ready? Go. Okay.
How do I, is it all?
We are now 36 minutes until we see the Integrity crew pass the Apollo 13 distance record. And joining me on console, I have Julianne Gross, the Artemis curation lead. Thanks for joining me today.
Thanks for having me. I'm very excited to be here.
We're very excited to have you. So can you tell me about your role as Artemis curation lead and what that entails?
Yeah, so for the overall Artemis campaign, I'm the Artemis lunar sample curation lead. That means I'm helping NASA to return the next set of lunar samples from the lunar surface. And for Artemis 2 specifically, I'm one of the science theme leads, and specifically I'm responsible, or the voice, for impacts, poles, and landing sites.
Fascinating. So what helped us select the targets that the crew is going to be photographing today?
So we had a plan coming in where we basically made a list of all the available targets during the April launch window, because before you launch, we wouldn't exactly be sure which targets would be visible. And so once we launched, we then were able to cut down on that list and prioritize our targets. And the 5 theme leads came together and really discussed and talked through which
the long lens configured for lunar flyby.
Which targets we could then see and prioritize. And so that made it into our plan. We worked then with timeline to make sure that all the targets are visible. Some targets are time dependent, like Earthset or Earthrise, and some targets will rotate out of view when Integrity starts going around the moon. And so we put these in early so that the crew has a chance to describe those to us.
Fascinating. I cannot wait to hear what they have to say. So we just heard them say that their long lens is configured. That's very exciting. And for us, when we look at the moon from Earth, what features are we seeing that the crew will also fly by today?
Yeah, so I really hope that people on Earth who are in nighttime will look up into the moon tonight. The features that the crew will see that we can also currently see is Aristarchus Plateau. Grimaldi is another feature. They're going to be sort of on our limb. And then Oceanus Procellarum, that really dark, large area on the near side that we can see. The crew is going to see that in the beginning. The more they fly around, the less of that they will see. So those are targets we will hear them describe early on in the flyby.
Fascinating. Well, and the crew has been training for years for this day. And so we're going to hear them make a lot of calls about what they are seeing on the moon. And they're going to use a lot of interesting terms that I myself need some brushing up on. So could you walk us through a few of the things that we'll hear them use to describe the moon, like albedo, exosphere, ejecta, just some of those major terms we expect to hear from the crew?
Yeah, of course. Albedo is basically a term of a reflectiveness of the surface. And so high albedo usually for the moon means bright areas, and low albedo means like darker areas. And so when you look into the night sky, you can see the high albedo areas are the white parts and the low albedo ones are the darker areas. Ejecta is when you have an impact and it ejects or throws out material that then ends up on the surface, and you can see that as sort of rays or ray systems. So you might hear them describe, I can see Ohm, for example, with its rays. It has an asymmetric rays coming out, and so we're excited to hear them describe that. You might hopefully hear stuff about color or color hues, and so if they can see any changes in those color hues from like white to gray to maybe brownish, we're excited to hear about that. Exosphere is the almost no existing atmosphere of the moon. It's barely there. But there is dust on the lunar surface that can get lofted up through electrostatic forces. And when the sun goes behind the moon, it can scatter forward on those dust particles and sort of like create a little glow on the horizon. And so we're really excited to see if the crew can actually see that.
This is so exciting. Thank you so much for walking through all of that with us. Julianne Gross, Artemis Curation Lead, we really appreciate you joining us here today, and good luck to your team.
Thank you. I'm really excited to be here.
We are now MET 4 days, 18 hours, and 49 minutes into the flight of Orion. This view of the moon from the Orion spacecraft as we get closer and closer. We're live here in Artemis Mission Control at Johnson Space Center in Houston, Texas, just about 32 minutes away until the crew surpasses the record set by Apollo 13 as the farthest astronauts to ever leave Earth. This view coming from a camera mounted on the tip of one of Orion's 4 solar arrays. Each array has a camera on its tip, and so we anticipate getting views throughout the lunar flyby. Of course, except during the point of loss of signal when the spacecraft flies behind the moon. Inside the cabin, the crew are configuring the inside of Orion for today's flyby, making sure they have everything just where they want it to help them take the pictures that they are aiming for the science team here on the ground. Coming up in just a few minutes, we will have a pre-lunar flyby conference. During that Lunar Flyby Science Crew Conference, our science officer here on console, Kelsey Young, will be speaking directly with the crew members about their targets, about their goals for today, what they expect to see, and what we are hoping to hear from them. We have a lot of milestones coming up today, so make sure you don't miss them. The first coming up, again, at 1:56 p.m. Eastern Time, the crew will pass the distance from Earth record set by Apollo 13 in 1970. At 2:45 p.m., lunar flyby officially begins. The crew will have that time on their schedules to begin photographing and providing audio recordings of what they are seeing on the moon. At 7:02 p.m., Orion will make its closest approach to the moon, approximately 4,070 miles away. Of course, all of these numbers are going to have to be confirmed following the flyby. These are estimates, and we are working with orbital mechanics. At 7:07 p.m., Orion reaches its maximum distance from Earth, approximately 252,760 miles away from us all. At 8:35 p.m., the spacecraft will enter a solar eclipse. The crew will become the first to see a solar eclipse from the moon. Ahead of the official beginning of flyby today, Kelsey Young, Artemis Science Flight Operations Lead, will be conducting a pre-lunar flyby crew conference. She will give information on camera setup, remind the crew of their intended targets, answer questions from the astronauts, and more. Young will help the crew set their targeting timeline, which counts down the time they have to image each target and what they'll be capturing next. She'll also remind them that the ground team will be calling for science sit reps, also known as situation reports. Those are essentially call-downs to report what they've been observing. They'll continue to do this even through their LOS, their loss of signal, as those communications will come down later on after they reconnect with us on Earth. This view in the cabin, you can see the crew members are already using their cameras, getting set up, and they have dimmed the cabin lights to allow them better visibility outside of the windows and fewer reflections. Now, 28 minutes until they become the humans to travel farthest from our planet.
Houston Integrity, we are ready for the conference on your call.
Houston is ready for the conference, passing you over to Science.
Good morning, crew. This is Science. We couldn't be more excited for a full day of lunar and planetary observations today, the first one in over 54 years. How do you hear me?
We hear you loud and clear, and Kelsey, you just got to know you're pulling us away from the moon right now, so let's go.
Message received. I will keep it tight here. I did just want to start with a thank you on behalf of the Lunar Science team and the entire lunar and planetary science community, of which you are absolutely a part, for what you've already done in this mission and what you're going to do today to inspire the next generation of scientists. I have to say Moonjoy is the new term that's already become our team's new motto, so thanks for that. In this conference, we'll cover hardware and config reminders, and then I'll just briefly, as you said, cover today's science plan. I'm assuming you already have your LTPs up. Confirm that, and I'll jump quickly into the cabin config reminders.
Okay, we have the LTP up just to give you a sit rep on board. You've got Reed and Christina on one PCD, and Ike has his own, and Jeremy has his own.
Copy that. That was going to be one of my questions for you, and I'll ask a question back. Is that the config that you and Christina plan to carry throughout the day for PCD use?
Negative, Kelsey. Our plan for PCD use is we have run the power cables to Windows 2 and 3, and we are going to leave one PCD. The yellow PCD will be in window 2, and the green PCD will be in window 3, and we will do that the whole day. And then the red PCD will be a rover.
Understood. Super helpful. Recommend when you guys switch in and out of PCDs to add your initials to your OneNote annotations, just so we can keep track of whose is who. And then given that you have 3 PCDs instead of 4, for the data transfer at the end of the day, recommend making a new subdirectory entitled For Science for your own photos, or with your initials, that we can keep track of which pictures came from which flashcards.
This view.
So, Kelsey, I just want to here's what we're doing. We have community cards in all cameras on board, and then when each astronaut approaches their camera, the intent is they will put their card into that camera for photos and then put the community card back in at the end of the session. But just know it is harder to manage cards than we thought, and we don't want to miss science, so it might end up a bit more disorganized.
Understood. Thanks for that essay. Just read the flashcard numbers down when you get a chance, and we'll follow your lead on the best thing to do operationally during the flyby. With that, I'll move on to Windows. So the window characterization DFTO you guys did a few days ago confirmed that Window 2 is ideal for imaging, so no change to config of photographer in Window 2, observer in Window 3, and science at reps in Window 1. Coming up on a handover. Be back.
Hang on, Kelsey. The way we have it configured, tell us if this is going to be wrong. Window 2 is the long lens with a shroud. Window.
As you heard, Science Officer called to the crew. We are now in a handover time period. We will regain communications with the crew very shortly. These are tracked, and we are currently on the Deep Space Network. This is the first time humans have used the Deep Space Network in over 50 years, given that we currently use the tracking data relay satellite systems in for the International Space Station. This view from Artemis Mission Control on the right is Kelsey Young. That's who you hear speaking with the crew. Young is the Artemis Science Flight Operations Lead, and we also look forward to speaking with her here today. Again, we are just about 22 minutes until we reach the Apollo record. We are in a handover of satellites with the crew aboard Orion.
The T-shirt shroud for the Z9 and solar, and then window 3 will be for visual observations, and window 4 is for floater.
And thanks, Integrity, for that read. We had a handover during that time, so I'm going to have to ask you to give that read back on window orientation for the crew again.
Okay, we are happy to change it, but the way we have it configured right now is window 1 has a T-shirt shroud for the Z9 for solar. Window 2 has the shroud for the long lens for both lunar and solar. Window 3 is for visual observations. Window 4 is for floater. And then the docking hatch window has had a great view, so we've done a lot of mapping through that as well.
All right, copy all, Reed. A note just on the window 1 T-shirt shroud that you can remove that for the lunar observation block if you want to, if you want that extra view for another floater, but defer to you guys on that. You are go to use the full 400 millimeter zoom on the long lens, but where possible, try to keep the end of the lens flush with the window to prevent imaging through the multiple window panes at an angle. And if you have to take an image at an angle, recommend you limit the max focal length to 200 millimeters or simply acquire the images at multiple focal lengths. Last imaging update as a result of the DFTO is that if you can take the images out of the left side of window 2 where possible, that is the best half the window. Understand that might not be possible with the shroud. Any other imaging questions from you?
Okay, copy that.
Okay, last couple reminders. Don't forget the ability to take the wave files to tag imagery that you are wanting to follow up on using the FN3 button on your camera. And then a couple quick notes on your LTP. We have refined your precise flyby timing since generating the LTP. Optimus has the correct timing for the LOS and AOS, but the LTP identifiers for LOS and AOS are roughly 2 minutes later than they will be in reality. Final LTP timing update is that the green line on your LTP should start automatically 45 minutes before the flyby. If it doesn't appear, let me know and I'll have troubleshooting steps for you. Last updates are on the eclipse, so only for that last hour today. Of course, remember if the sun is in view to use your eclipse glasses. And reminder that we will have a few activities for you prior to the eclipse to reconfigure all 3 cameras for corona and deep sky observations. These activities, some of which will occur during the forward link LOS, so we wanted to flag it for you now. Any questions before I cover the last 2 reminders?
No, we have no questions on that.
Last couple eclipse reminders, the sunset period and the first roughly 23 minutes of the eclipse will fall during that forward link LOS, but we'll still have a return link, and we're still looking forward to your science sit reps and observations during that time. And I do have a reminder for you on your preferred starting config for the eclipse in terms of role responsibility. Let me know if you want me to read that up or if you guys have that in your minds already. And if no other questions on config, I'll give you a few science-focused reminders.
Give us a quick high level, but we see it in Optimus, and I think we got it squared away. But give us your quick Kelsey high level.
Okay. A couple changes from the first LTP you studied is that Glushko is the only feature that the same pair will view twice. That's Reed and Jeremy. That's why that's the only target you see that is marked as 1 of 1 and one of two and two of two. So OM and Oriental are in there twice, but they're by different pairs, which is why you don't see them marked accordingly. A note from feedback on your observations so far over the last couple days, a reminder that if you note structure and texture as well as color and albedo, please note any correlation between the two, and also a reminder that negative observations are still valuable science. So a lack of color or a lack of structure associated with color is also valuable. A reminder also that your observations so far indicate it will likely take some time for your eyes to adjust. We especially heard that around your terminator observations and your color observations. So reminder to know that your eye adaptation is going to kind of come in throughout your shift, and let us know when you start to see that nuance. Last reminder is around Earthset and Earthrise. When you're viewing us back here at home, you'll be looking directly at Asia, Africa, and Oceania. So I'm sure people watching from those places here on Earth will want to give you all a wave as you take their picture. Any other questions for me?
And Kelsey, hey, when you're talking window 2 left and right side, just can you say towards window 1 or towards window 3, and then we'll know that we are talking the same language?
Absolutely. So I mean that the side of window 2 closest to window 3 is preferred for imaging.
Okay, the side of window 2 closest to window 3 is preferred for recording. Stand by, we'll talk to the crew.
Again, we are in our pre-lunar flyby science conference with Kelsey Young. Kelsey Young is the Artemis Science Flight Operations Lead, speaking with the crew aboard Orion. They've been training for this moment for years, and this is their last opportunity to get some further pointers and information.
Kelsey, for the T-shirt shroud, what window does the science team think will have the best view? Is it window 1 or window 4?
The only time we're strongly recommending use of the window shroud.
The T-shirt window shroud for the eclipse viewing. Which window is primary for Z9?
Window 1.
Okay, awesome. So we have got that all set up. And just to be 100% sure, window 1 is the most port window by the food warmer. Window 2 is right in front of seat 1. Window 3 is right in front of seat 2. And window 4 is on the starboard side by the side hatch. Do you agree with all that?
We agree on the ground. Good readback.
Okay, that's awesome. Kelsey, we're going to close with happy words. It's just incredible. I wish you were up here to see all the smiling faces, to hear all these terminologies being thrown around, and we are just fired up to get started on this day. Let me pass the mic around if anybody has anything to add.
Kelsey, it's so great to hear your voice on the loops. I just want to channel everything that you guys are probably feeling right through my eyes and heart. It is awesome to see the side of the moon. You guys made us excited for this day, and we couldn't appreciate it anymore. And we are ready to hopefully deliver on all the awesome training you guys have provided.
I'll just add, Kelsey, it is blowing my mind what you can see with the naked eye on the moon right now. It's just unbelievable.
Kelsey, and to the whole Lunar Science team, all of you, all the work you put into this, we're just grateful. Can't wait to get going. And thank you for the tipper, for Carol Crater, and for Integrity. We can see them, and we've imaged them, and can even see with the naked eye. Quite impressive. Thank you so much.
Beautiful words, you guys. Thanks so much. And I got video of the science team right now, and they are all absolutely buzzing. Looking forward to today.
Okay, we're heading into the timeline. Cheers, guys.
pre-lunar flyby science conference with Dr. Kelsey Young. Young has served as the Artemis Science Flight Operations Lead, getting the crew ready. And we're live in Artemis Mission Control in Houston, but we are not the only room monitoring today's flyby. As you heard Young mention, in this same building and just down the hall, a multidisciplinary lunar science team supports the Artemis II crew in real time, including experts in lunar geology, impact cratering, volcanism, polar science, imaging, and visualization. There are two integrated facilities, and the first is the SIR, which is what you have right here. That's the Science Evaluation Room. They are embedded within Mission Control to provide science input during live operations like what we see today. Additionally, and not pictured, we have the Science Mission Operations Room, a back room that processes data, evaluates imagery, and supports rapid analysis. Our science officer on console in Mission Control Houston serves as the primary interface between the science team and the flight controllers, ensuring science priorities are represented during mission execution. Again, today, that's Dr. Kelsey Young, who will be speaking with the crew during the time they're behind the moon. We will be speaking with her once the crew is behind the moon and out of communication with Earth. Back inside the Orion spacecraft on your left, closest to the camera, NASA astronaut Christina Cook. To her left, NASA astronaut Reid Wiseman. To his left, Canadian Space Agency astronaut Jeremy Hansen. And all the way in the back, NASA astronaut Victor Glover, our Artemis II crew. We are now approaching 8 minutes until the crew surpasses the Apollo 13 record. Currently 12,599 miles away from the moon, 248,507 miles away from Earth. You may also hear the Orion spacecraft referred to today as Integrity. This was named by the Artemis II crew. It is
Integrity crew. We have Reid's family in the viewing gallery. You're welcome to say hello.
Well, whether you're being serious or you're kidding around, that is awesome to hear. Thanks, Jenny. And hello to Ellie and Katie. I don't know who else is there, but it's great to know that you're in Mission Control right now, following along. We are having a blast up here, and the view of the moon is absolutely amazing.
I'm seeing a lot of hearts come out of the viewing gallery and even more smiles. Thanks, Reid. Copy heart, copy bracelet.
That call from Capcom, Jenny Gibbons, Canadian Space Agency astronaut and Artemis II backup crew member, letting Reid Wiseman know that he has family here to support him today in the Artemis Mission Control viewing room. As I was mentioning, we have the Orion spacecraft flying today. However, the Artemis crew members named their Orion spacecraft Integrity, so you will hear calls to this entire crew with the name Integrity. They say that the name Integrity embodies the foundation of trust, respect, candor, and humility across the crew and the many engineers, technicians, scientists, planners, and dreamers required for mission success. This view live from the outside of Orion as we continue. Preparing for our lunar flyby, now less than 5 minutes from surpassing the record set by Apollo 13 astronauts for the farthest humans to travel from Earth. This will not be the farthest that Integrity travels today. They will continue until they reach approximately a distance of 252,760 miles. That would be about 4,105 miles farther than Apollo 13. However, these numbers are our targets, and we will get confirmation on those numbers as soon as we possibly can and share them with you all. We talked a little bit about what to expect from the crew, whether that's taking photos or making audio recordings. To get a little more detailed, Reed Wiseman and Jeremy Hansen will be up first to capture imagery and record audio on the portable computing devices. You hear those referred to as PCDs, while Victor and Christina serve as the support members. The crew will switch windows and roles halfway through their shift, and 1 hour and 5 minutes later, Victor Glover and Christina Cook will be the next crew members at windows 2 and 3 to take photos and make annotations, while Reed and Jeremy take on those support roles. There are 5 viewing blocks, and the crew will swap out with each one. During 2 of the blocks, the 2 support members will also be able to enjoy their midday meal. At least 3 times per block is a science sit rep. Again, situational report. This is partially an operational status, reporting back if they missed any targets or gotten any specific ones, if they have issues with their camera or any other operational items. The other part is an actual description of the moon. This task is done by one of the support team astronauts, so that's not the crew currently taking photos or making annotations, but they do have windows 1 and 4 that they can float up and provide that information from. If you watch the entirety of the flyby, you'll also notice the crew will be photographing some targets multiple times to get observations in different lighting conditions. This is due to Orion changing their location throughout the flyby. What this crew will be able to capture in a couple of hours of the same targets in different lighting would take orbiters years to do because of solar and spacecraft positioning. This crew has studied the moon extensively, and they're also familiar with what the science team calls the Big 15. These are 15 features that they've memorized, so at any time, they'll be able to see 5 of those and help orient themselves and where they are around the moon. Those targets are diverse and complex in their geologic history, and observations of them could help answer some big-picture science questions. If you've been following the mission, you can see that the configuration of the cabin is a little bit different than what it looked like on launch day. After ascent, the crew were allowed to reconfigure their spacecraft, and you can see that they've taken down seats. They have also taken away footrests. This gives them more opportunity to move about the spacecraft. Orion itself has 330 cubic feet of habitable volume. That's about the size of 2 minivans and is 60% more cubic volume than the Apollo spacecraft. We are standing by for the Integrity crew aboard Orion to surpass the Apollo 13 record.
Integrity crew, on April 15, 1970, during the Apollo 13 mission, 3 explorers set the record for the farthest distance humans have ever traveled from our home planet. At that time, over 55 years ago, Lovell, Swigert, and Hayes flew 248,655 statute miles away from Earth. Today, for all humanity, you're pushing beyond that frontier. Integrity, over to you.
Yeah, from the cabin of Integrity here as we surpass the furthest distance humans have ever traveled from planet Earth. We do so in honoring the extraordinary efforts and feats of our predecessors in human space exploration. We will continue our journey even further into space before Mother Earth succeeds in pulling us back to everything that we hold dear. But we most importantly choose this moment to challenge this generation and the next to make sure this record is not long-lived.
Thank you, Integrity, and congratulations to you and the rest of the Artemis II team.
Thank you, Houston. We have a couple more things we'd like to take this moment for. Our science team helped us out with a couple of relatively fresh craters on the moon that have not been previously named, and our crew would like to propose a couple of potential names for those items or those areas. And we spent a bit of time this morning looking out the window, and we're able to see them now both with our naked eye and through the long lens, and so we feel this is a good time to send this down, and a special shout out to Kelsey for helping us with this. The first one we'd like to suggest is a named crater in honor of our great spacecraft, Integrity. And so if you were to look at Oriental on the far side and then draw a line straight up to Ohm on the far side, relatively in the middle is an unnamed crater, and we would like to suggest it be called Integrity in the future. And the second one, and especially meaningful for this crew, is a number of years ago we started this journey in our close-knit astronaut family, and we lost a loved one. And there's a feature in a really neat place on the moon, and it is on the near side, far side boundary. In fact, it's just on the near side of that boundary, and so at certain times of the moon's transit around Earth, we will be able to see this from Earth. And so we lost a loved one. Her name was Carol, the spouse of Reed, the mother of Katie and Ellie. And if you want to find this one, you look at Glushko, and it's just to the northwest of that, at the same latitude as Ohm, and it's a bright spot on the moon. And we would like to call it Carol, and you spell that C-A-R-R-O-L-L.
Integrity and Carroll Crater. Loud and clear. Thank you. As the Artemis II crew passed the record set by Apollo 13 for the farthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, Canadian Space Agency astronaut Jeremy Hansen shared.
We're getting ourselves all put back together now, and we are going to dim the cabin lights and prepare for our science objectives ahead. Thank you.
Sounds good. We're doing the same down here, and you are maneuvering to your observation attitude.
As we pass that Apollo 13 record of the furthest humans to ever fly from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time, the Artemis II crew shared some poignant words, specifically Canadian Space Agency astronaut Jeremy Hansen. The crew also called down 2 craters not yet named that they would like to name. One, Integrity, in honor of their spacecraft, which they have named. That's near the Ohm crater. Another near Glushko, which is a bright spot, named Carroll, in memory of Reed Wiseman's wife. There was a moment of silence here in Mission Control Houston. And now the team and the Artemis II crew are ready to begin their lunar flyby. We are 4 days, 19 hours, 31 minutes mission elapsed time of the flight of Artemis II, our 4 astronauts aboard Orion. Today is our lunar flyby day. The spacecraft is currently about 12,000 miles away from the moon, and you can keep up with the distance from Orion to the moon and Earth by visiting nasa.gov/track Artemis. Or you can just stay with us here because we're going to be telling you throughout the day. They are currently 248,834 miles away from planet Earth. Coming up next on the crew's timeline today will be their cabin configuration portion. You heard some calls down to Science Officer Dr. Kelsey Young earlier about how they have configured the cabin so far. This is just a little bit more of timelined activity for them if they need to further do so. On flight day 3, the crew had time on their schedule allotted for configuring the spacecraft cabin for how they intended to arrange it today. Of course, they had to take down that configuration for another test yesterday of their Orion Crew Survival System suits. But configuring it on flight day 3 allows them the opportunity to get a chance to see what works for them now that they are in the microgravity environment. Again, the crew is about to begin their cabin configuration portion of their timeline, though they have been working that already, as well as potentially during their post-sleep period this morning. The official lunar flyby observations are slated to begin in just about 40 minutes. That's when we'll have the crew at the windows photographing the moon, as well as making calls down about what they are seeing. Again, we are live here in Artemis Mission Control for the duration of the flyby. Currently, the Orbit 1 flight control team is on console. This room is staffed 24/7 from the time before the astronauts step foot on the rocket until the time they splash down and are safely recovered in the Pacific Ocean on flight day 10. Again, this is Artemis Mission Control here in Houston. We are now 11,777 miles away from the moon. We did pass the Apollo 13 record of farthest humans away from Earth at 12:57 p.m. Central Time, 1:57 p.m. Eastern Time. That distance, 248,655 statute miles from the Earth, continuing to be exceeded by the crew. They will reach their farthest distance from the Earth around 6:07 p.m. Central Time. At that time, they will be in an LOS, or a loss of signal, with us on Earth, as they'll be flying behind the moon. As the crew gets into their cabin configuration preparations, we are joined by Dr. Sarah Noble, the Artemis Lunar Science Lead. Thanks for joining us here today.
Yeah, it's quite a day.
Yeah, we are very excited. I can only imagine how you guys are doing over there. So tell me a little bit about yourself and what your role is for Artemis 2.
Sure. So I'm the Artemis Lunar Science Lead. So over the entire campaign, and my job is basically to make sure that as we have this big adventure back to the moon, we actually learn new things about the moon.
Fascinating. So why is the moon such an important destination today?
Yeah, so the moon is a pretty amazing place. It is a great place to learn about basic fundamental processes that happen on like all the planets, like cratering and volcanology. And also it is, part of our Earth-Moon system. And, the Earth recycles its rocks pretty well, right, through plate tectonics and weathering and whatever. Most of the rocks on the Earth are geologically young. But on the moon, we have the entire record that goes back 4.5 billion years since we formed. And so if we really want to learn about what was happening in that period, like the moon is really the only place we can go.
We're also thinking about going back to the moon, and we want to go to the lunar South Pole. So what makes that such an interesting destination?
Yeah, the South Pole is cool, right? It's far away from the places we went during Apollo. It's different kinds of rocks there, some of the oldest rocks on the moon. It's also a place where we think there might be resources like water. There are craters that really never can see the sun because of the low sun angles there, and they get very cold. And we think that water and other things can build up in those craters, and so we're very interested to see what that might do for us.
I'm very interested as well. So for some of our viewers who might be new to this, what does lunar science look like during an Artemis mission?
Yeah, it's pretty exciting for us as we have sort of built this from scratch to try to understand how we can best use the crew to support our science. And so, we've developed a system. We've got a team in place. We've got a back room here in this building called the SIR, the Science Evaluation Room. And there's in fact a back room to that back room over in another building here at Johnson Space Center where we've got our teams of scientists working really hard. They're actually speaking to this room through our science officer. This is now the first time we've ever had a science officer in flight control room. So we're pretty excited about that. So we have a really voice out and up to the crew.
I know, it's been so exciting to hear Dr. Kelsey Young speaking directly with the crew today, now so close to the moon. And we have a live view here of the science operation, or the science evaluation room. So this is where the majority of your team is today, is that right?
Yeah, that's right. This is a big chunk of our scientists. You can see them in there now working hard, trying to get ready for the day. And then again, there's a second room where we have a lot of our data folks, where the data will first come down and they'll sort of sift through the data and get it ready for this team to take.
What's the mood like right now in the
E aí um momento legal, que também rolou agora há pouco, as famílias dos tripulantes da Artemis 2 estão presentes no centro de controle da missão em Houston, e a transmissão da NASA ressaltou isso, né? Eles falaram lá que a família do Reid, por exemplo, está ali na galeria de observação, e aí um dos momentos ali de maior emoção foi justamente quando um falou com o outro, né? E então eles têm essa, mesmo à distância, eles estão conseguindo falar com os familiares. Quando o Wiseman gesticulou com as mãos, né, fazendo ali um formato de coração com as mãos, era justamente uma resposta aí à família. Então, mesmo distantes, eles conseguiram aí um contato com a família, mesmo que indiretamente. Bacana isso.
Muito bom. A cratera de Aristarco, né, que foi citada aí também, ela é uma das crateras mais destacadas, né, na superfície lunar, porque é uma cratera muito jovem e por isso ela brilha muito, né, em contraste grande com a parte escura ali do mar onde ela está localizada, né. E é interessante que foi numa dessas crateras, por exemplo, que o astrônomo brasileiro Rubens de Azevedo notou uma anomalia na Lua quando estava se aproximando a Apolo 11, né, do momento histórico, né, do primeiro ser humano a pisar na Lua. Tá? Então, enquanto o Michael Collins estava orbitando a Lua, o Rubens de Azevedo estava observando a superfície lunar em busca dessas anomalias e ele percebeu um brilho estranho na cratera Aristarco e informou a NASA, que prontamente entrou em contato com o Michael Collins em órbita da Lua, confirmou, né, de lá, da órbita da Lua, né, o mesmo fenômeno observado. Nessa imagem aí. Dá para ver a Copérnicos, que é essa mais clara do lado direito, né? No mar, a Aristarco ela estaria um pouco acima, né, da Copérnicos. Mas ela é pequenininha.
Isso, mas imagens da Lua. Já dá para dizer que a Artemis já está perto, né, do nosso satélite natural. A gente sabe que essa não é a máxima aproximação. A máxima aproximação ainda vai acontecer, né, mais tarde. Mas a Artemis já, se a gente comparar com as imagens aí de horas atrás, né, especialmente aí dos últimos dias, a gente agora já consegue ver a Lua bem pertinho, e a gente vai ter a máxima aproximação. E aí, Zurita, até falando, né, sobre os próximos passos aí desta segunda-feira, uma das missões aí, como eu disse agora há pouco, dos astronautas é justamente ficar fotografando ali, registrando, né, tudo o que for possível, né, da Lua. Então, assim, que tipo de resposta a gente pode esperar? Que tipo de... assim, o que se espera, né? O que você esperaria de descoberta, de contribuição, né, para além do que a gente já tem, como, por exemplo, esse recorde, né, de distância quebrado pela missão Artemis 2, né? Relembrando para quem chegou agora, a audiência rotativa, né? Primeiramente, deixe seu like, deixe seu comentário aqui na nossa transmissão, e inscreva-se no Olhar Digital, caso você não faça parte da nossa comunidade. Mas para quem chegou agora, outro aviso importante nunca ninguém foi tão longe, né, como o quarteto da missão Artemis 2. Eles bateram o recorde da Apollo 13 de 1970, ultrapassaram os 400 mil quilômetros de distância. Então esse já é um recorde para lá de importante da missão Artemis 2. Mas nessa função, digamos, um pouco mais manual, né, dos astronautas, né, que vão ficar registrando ali, fotografando a Lua, o que a gente pode esperar além de belas imagens?
Eu não sei se conseguiríamos descobrir alguma coisa diferente a partir dessas imagens, né, feitas a partir da Orion, tá? Mas, assim, do que depender do que já foi divulgado de imagens, né, teve uma imagem divulgada nesse final de semana de uma foto de longa exposição do lado escuro da Terra, iluminado pela Lua, que é uma coisa fantástica. Eu nunca tinha visto uma foto como essa, eu acho que é uma imagem inédita, né? E, de repente, a gente ter uma coisa assim, né, uma foto como essa a partir da Lua seria mais uma coisa fantástica, né? Então, da Lua não vai ter quem ilumine, né, o lado escuro da Lua, né? Mas a gente poderia, por exemplo, ter uma foto a partir do lado oculto, né, do lado da Lua, pegar a Terra iluminada por ela, iluminada pela Lua. Então, é algo que, de repente, seja interessante da gente ver.
Teve algo que a gente comentou um pouquinho antes de entrar no ar, que eu achei bem bacana, que eu estava relembrando com você, porque na quinta-feira a gente teve a manobra de injeção translunar, colocou a Artemis em direção à Lua, né? Foi logo um dos primeiros movimentos após o lançamento, e nesse dia as imagens estavam muito ruins. E a primeira coisa que eu pensei, eu falei, putz, a hora que ela estiver próximo da Lua, as imagens vão estar piores ainda, né? Porque se ela ainda perto da Terra tá com a imagem nessa qualidade, isso aqui só vai piorar, a gente não vai ter imagens da Lua. Eu estava preocupada, falei, a gente não vai conseguir transmitir a Lua, não teremos a Lua. Mas aí estamos sendo a Lua, e belíssimas imagens, aliás, o sinal foi melhorando com o tempo. Eles estão fazendo uma live direta, né, com imagens da cápsula Orion, a live tem algumas quedas, mas no começo caía praticamente o tempo inteiro, e agora, desde ontem, começou a ficar um pouco mais estável. E aí você me falou que na medida que a cápsula vai se afastando da Terra, o sinal vai melhorando. Como que isso acontece, Zurita? Por que ela melhora o sinal conforme ela se afasta?
Então, é porque as espaçonaves da NASA, elas se comunicam com a Terra através de um sistema chamado aí de Deep Space Network, né, que é uma rede de comunicação com espaço profundo. São basicamente 3 radiotelescópios gigantescos que são distribuídos, né, num ângulo de 120 graus aí na superfície da Terra. Tá? Então, eu vou pegar aqui a localização de cada uma dessas antenas, né, mas elas estão cada uma num canto do mundo. E aí o que acontece? Quando você está muito próximo, né, da superfície da Terra, pode ser que você não tenha uma boa visão para nenhuma dessas 3 antenas. Tá? E aí a comunicação cai, né? Ela está muito sujeita aí à atmosfera, né, a interferência atmosférica, e acaba caindo a comunicação. Quando a nave vai se afastando da Terra, aí essa comunicação melhora, porque as antenas conseguem pegar ela mais facilmente, né? Qualquer uma pelo menos uma das 3 antenas consegue uma boa visada para a espaçonave. Tá? Então, isso é uma coisa que acontece mesmo com as naves que estão se comunicando através do Deep Space Network. A gente não vê isso nos lançamentos da SpaceX, porque eles utilizam a Starlink, né, que tem satélite espalhado aí por toda a órbita baixa da Terra.
Aí teve mais um momento, naquele momento emocionante também, um detalhe bacana de falar, né? A gente teve ali a fala com, né, a mensagem dos próprios familiares, mas também o astronauta Hansen, né? Ele aproveitou para fazer uma homenagem póstuma, dedicando uma das crateras lunares, né, à esposa de um dos membros que morreu de câncer em 2020. O nome dela era Carol, esposa do Reed, né, do astronauta Reed, mãe da Katie e da Ellie, disse o comandante, enquanto os astronautas a bordo já, né, enxugando as lágrimas. Foi aquele momento também que a gente acompanhou. Então, a cratera Carol, recém-dedicada, pode ser encontrada perto da cratera Glushko, é o que informa aqui a NASA. Então a gente tem também essa homenagem, né? Por isso que foi um momento bastante marcante. A gente já tinha falado que eles tinham conversado com familiares, mas, então, só repassando, né? Nesse momento foi bastante emocionante, o Hansen pediu, em nome da equipe, que nomeassem 2 crateras relativamente recentes na Lua. Ambas foram vistas a tripulação a olho nu. Então, uma delas foi batizada de Integrity, em homenagem a... Deixa eu até checar isso aqui mesmo, foi em homenagem a nada? Isso, foi nomeada de Integrity, né? Aí por causa da Orion. E a outra, perto de uma cratera bem brilhante, conhecida, né, essa Glushko que eu falei, foi sugerida como sendo batizada de Carol, em homenagem à falecida esposa do comandante da missão, o Reed Wiseman. Ela faleceu de câncer em 2020. Então, esse foi um momento bastante emocionante que a gente captou aqui na nossa transmissão, né? Todos os astronautas bastante emocionados por um conjunto, né? Primeiro que eles tinham acabado de bater um recorde, né? Aí o recorde de distância, né? Em relação à Terra. Aí também eles tiveram, né? O contato ali, os astronautas teve um contato indireto ali com familiares que estavam no centro de comando ali da NASA. E também nesse momento em que eles batizam uma das crateras com o nome da esposa do Reed Wiseman, que faleceu em 2020 de câncer. Então, foi um momento bastante emocionante por essa soma de fatores, né? Os astronautas, todos os 4 ali se abraçaram, enxugavam as lágrimas. Foi um momento bem emocionante aqui na nossa transmissão.
Uma coisa bacana que, enfim, que aconteceu hoje, Capozzi, se a gente tiver um tempinho para falar agora, é que o Zurita estava comentando sobre a Apollo 13, né, que foi o recorde atual de distância da Terra, e tem uma matéria muito bacana no site do Olhar Digital da Flávia, que os astronautas da Artemis 2 hoje foram acordados por uma gravação do Jim Lovell, que foi o capitão da Artemis 13. Ele faleceu ano passado, em 2025, mas ele deixou uma mensagem gravada para a tripulação da Artemis 2. O Jim Lovell, que também esteve na Apollo 8, que foi a primeira missão a orbitar a Lua, né? Então foi essa missão prévia antes da Apollo 11, foi a primeira que conseguiu fazer isso, e o Jim Lovell foi capitão da Apollo 13, que fez essa trajetória de livre retorno, bateu esse recorde, teve todo aquele retorno dramático para a Terra que o Zurita explicou, e hoje os astronautas acordaram com a mensagem dele, a mensagem, enfim, que ele deixou, mensagem póstuma, né? O Jim Lovell, infelizmente, faleceu ano passado. Ele disse que tem muito orgulho de ter batido esse recorde, de ter sido o primeiro astronauta, de ter feito parte do primeiro grupo que orbitou a Apollo 8, que tem muito orgulho de passar esse bastão para essa tripulação nova. Enfim, que eles estão agora lançando as bases para as futuras missões em Marte, que é um dia histórico, que eles são culpados, mas que, enfim, para eles apreciarem a vista. Então, uma mensagem bem bacana do Jim Lovell, mensagem póstuma deixada por ele, mas, enfim, quando ele faleceu já tinha, os astronautas já haviam sido escolhidos, já haviam sido anunciados, então, enfim, ele teve a chance de deixar um recado para a tripulação da Artemis 2. E, enfim, acho que ele melhor do que muita gente entende entendia, né, o que eles estão passando.
Sem dúvida, esse também foi um momento muito, muito bonito, né? Quem quiser ler a mensagem completa, é só acessar a matéria que está no olhardigital.com.br, que aí tem a mensagem completa, mais um momento emocionante, né, dessa missão Artemis 2. E aí, só completando a informação, né, Integrity é justamente o nome dessa espaçonave, a cápsula é Orion, né, o conceito cápsula é Orion. Mas as cápsulas, né, as diferentes cápsulas, elas também têm nomes ali, como, por exemplo, na SpaceX, a gente tem as cápsulas, né, Dragon, Freedom, enfim. Então, neste caso, né, essa nave Orion, ela chama Integrity. Então, uma das crateras batizadas de Integrity, por causa disso, a outra batizada com o nome de Carol, né, como eu disse, em razão de em homenagem à esposa de um dos astronautas que faleceu em 2020, depois de um câncer.
É bem confuso porque eles só chamam de Integrity a cápsula. Eles falaram que Integrity é
a Orion.
Exato, aí fica bem confuso, mas realmente Integrity é um apelido, né, pra gente brincar assim, dessa versão da Orion.
Perfeito. Bom, a gente agora já passamos aqui, né, mais de 3.000 pessoas ligadas aqui com a gente, ao vivo, no Olhar Digital. Convido vocês a deixarem o like de vocês, a se inscreverem no nosso canal. Vocês fazem parte da nossa comunidade. E você, que não conhecia aqui a nossa comunidade, inscreva-se no nosso canal, faça parte da comunidade do Olhar Digital, a comunidade de tecnologia que mais cresce no Brasil, a comunidade que mais entende de tecnologia no Brasil. Agradeço a mensagem de todo mundo. Quem tiver, gente, ó, a gente tem um super craque aqui, astrônomo, o super craque Marcelo Zurita, que está com a gente todas as semanas, noite, com todas as informações da ciência, da tecnologia, e em tempos de Artemis, temos dado um show de cobertura, né, da Artemis, e aí convido todo mundo a participar aqui com a gente, e deixe a sua dúvida para o nosso super craque Marcelo Zurita responder. A Lua, acho que vale a pena atualizar esse ponto. Não teremos um pouso na Lua dessa vez. A gente está na missão Artemis 2, é a primeira missão tripulada. A Artemis 1 não foi tripulada. A Artemis 2, ela é tripulada, mas não vai pousar na Lua. O pouso está previsto apenas para a Artemis 4. Então vai demorar mais um tempinho aí, mais um ano e pouquinho, né, Lucas, para a gente ter... A gente está em 2026? Então tem mais um tempinho aí para a gente ver novamente o homem pisando na Lua. Por enquanto é só uma voltinha mesmo, mas como o Zurita explicou há pouco, essa voltinha já vai ser bastante relevante para a nossa ciência.
A Artemis 4 está prevista nesse momento, pelas previsões da NASA, 2028, né? Seria em 2027, mas era uma previsão já bastante otimista. Agora, 2027 deve ser a Artemis 3 e 2028 a Artemis 4 e, teoricamente, a Artemis 5 também no mesmo ano. Falaram que eles pretendem fazer 2 pousos na Lua, utilizando os 2 módulos de pouso diferentes da SpaceX e da Blue Origin, ou um módulo que estiver pronto, se um dos 2 não ficar pronto até lá. Mas deveremos já ter Artemis de novo ano que vem com a Artemis 3, que vai testar os módulos de pouso. Então ela seria uma missão que pousaria na Lua, mas agora ela não vai mais pousar, ela vai apenas fazer um caminho parecido com o que a Artemis 2 está fazendo, mas ela vai testar a conexão com os módulos de pouso aí, tanto o Blue Moon, desenvolvido pela Blue Origin, quanto a Starship Lunar, versão que está sendo desenvolvida pela SpaceX.
Exatamente, a NASA ela não traz ali, ela fala início de 2028, né? Então pode ser
aí
de
temos uma data ainda.
1 ano e meio a 2 anos, mais
Exatamente.
ou menos.
Esses prazos são um pouco flexíveis, né? Então muita água vai rolar até lá.
Não, basta ver a própria Artemis 2, né? A gente está aqui há algum tempo falando e tinha expectativa da Artemis 3, né? Já ir pro pouso lunar. Então os planos eles vão sendo feitos e refeitos. Mas o fato é que agora...
originalmente para 2024, aí foi sendo adiada e a gente conseguiu acompanhar agora.
Só 2 aninhos de atraso. Mas essa é uma seara, né? A corrida espacial. Essa é uma seara que, enfim, existem imprevistos. E agora a gente tem, olha só, agora são 3h36 no horário de Brasília. Eu queria repassar aqui os planos, né, para nossa audiência rotativa. Deixa eu abrir aqui os planos certinhos. A gente já teve, né, ali por volta de 2h56, a tripulação superou o recorde de maior distância da Terra já alcançada por humanos. Esse recorde era da Apollo 13 em 1970. Por volta ali das 3h10, a tripulação comentou, né, a quebra desse recorde. Tivemos um momento bastante emocionante ali pela quebra do recorde, pelo contato com familiares, né, de uns astronautas e também pela homenagem, né, que fizeram, como eu expliquei há pouco. Uma cratera da Lua foi batizada com o nome da esposa de um dos astronautas que faleceu de câncer em 2020. Então foi um momento bastante emocionante ali no meio da tarde, né, há poucos minutos atrás. A tripulação ela configurou, né, a cabine da Orion para operações de sobrevoo. A Orion, né, a cápsula, vai ter a distância máxima da Terra ali no começo, por volta das 8 horas da noite. Vai ser basicamente junto, né? A maior aproximação da Orion com a Lua está prevista para as 8h02 da noite, e a maior distância da Terra prevista para as 8h07 da noite. Então, vão ser basicamente aí esses dois pontos, né, fundamentais dessa missão, praticamente simultâneos, né? Mas antes disso,